Hello vlog, welcome to my guys. Pugustag intro ani. Hello sa akong mga strength of materials sa students last sem nga namasar lang tungod sa quarantine. Ito joke lang. So di mo daw sila mag-subscribe, hindi sila ma-mention. So hello kinda Bernice Ulay, giya mga dabarkats. So for this problem, it's a combination of normal and shear stress. So we have a piece of wood here, block of wood. So as you can see, we have dimension of 3 by 3 inches by 1 inch. So this problem we're using English units. So we have a tensile force on both ends, 85 pounds. So we're asked actually to find the normal and the shear stress at the section, which is 15 degrees from the horizontal. So section AA. So that's where we're going to find. So first, cut the block. We cut the block at the section AA, which is 15 degrees from the horizontal. And if we look into the isometric view of the cut section, we have this area. No? So this is our this is the cut section, and we have the resulting force here. This is reaction forces, internal forces. We have the parallel or tangent force is the shear, and then you have the perpendicular force or the normal force is denoted by N. So this is the force causing the normal stress since it's perpendicular to the area, and then the V, which is the tangent to the area, is causing the shear stress. So how do we find the shear stress and the normal stress? So solution, again, our working equation for normal stress is just this one. Sigma is equal to P over A, which in this case is just normal force over area. And for tau, we just have the V over A, which in this case is the same. We have already denoted the tangent reaction force as V. For the area, this is the shear area, or this is the area, the normal area and the shear area. So how do we get the area? It's just area equals the L times 1 inch, and L can be solved by using this triangle. You have here 15 degrees, and then you have 3 inches. So this height here is just the same with the height here. Hindi medyo parehas drawing, but basically the same. And then you have the L. So sine 15 is equal to 3 over L. So L is just equal to 3 divided by sine 15 degrees. Therefore, your area is just equal to 1 inch times 3 over sine 15 degrees inches. So area equals 11.59 inches square. So that's all we need. For the forces, we can actually break the 85 pounds. We can actually make use of the X and Y. So we can have the vertical Y and the horizontal X, as we usually do. Or we can break the 85 pounds into components aligned with the axis of the N and V forces. So we can have the 85, for example, or breaking 85 into components. The 85 pounds into components. We have horizontal 85, and we are solving this into, this is 15 degrees, and we have this one, this is the 90. So this is now your 85 at the X prime axis, and this one is your Y prime axis. X prime and the Y prime. So if you're go back to the original drawing, we'll have this as the x prime, then you have the y prime. So just so that you have a consistent axis when we come to summation of forces on x and y. So to solve the n and the v, we'll have summation of forces first at the x prime equals 0. We will have v minus, so the component for at the x prime direction for 85 is just adjacent over hypotenuse, no? So this is now your hypotenuse, this is your adjacent side. So 85 cosine 15 equals 0, no? So this is of course directed to the positive x prime direction, and remember that your v is directed in the negative side, negative x prime direction. So again cosine, because just make this clearer. So you have components of the 85 pounds. You have this one, this is the for the x prime, this one is for the y prime, and then you have the 85. This is the adjacent side, this is the opposite side, and this one is the angle 15 degrees. So these are the components of the 85 pounds, component along the y prime direction and the component along the x direction. That's why we have this 85 cosine 15 degrees, because v is somewhere right here, no? V is somewhere right here. Then of course you have the n, and then you have the v. So that's it. So v is just equal to 82.90 or 0.1 pounds. Summation of forces along the y prime direction for 0, you have the n. So in the y prime direction, go back to the original. So you have the n, and then you have the also the component of the 85 pounds in the y direction, y prime. Again, you have the opposite sides. So the y prime is directed to the negative y prime direction. Here n is directed in the positive y prime direction. 85, it's the opposite now. This is opposite over the hypotenuse. Sine 15 degrees equals 0. So n is now equal to 22 pounds. So now we have the n and we have the v. We can solve for first the shear stress. So the shear stress is just equal to v over a. We have the 82 pounds over area, which is we solved earlier, 11.59 inches square. Tau equals 7.08 psi. For the normal stress, sigma is equal to n over a, which is equal to 22 pounds divided by the area, which was computed earlier. And then you have the sigma is just equal to 1.90 psi. So these are the values of your shear stress and normal stress at section AA, which is 15 degrees from the horizontal. So again, this is a combination of normal and shear stress. The V, which is tangent to your sheared area, causes the shear stress, and the normal force, which is perpendicular to the area, causes your normal stress.